Okay, so we're going to look at igneous rocks today. We're going to cover it, give an overview for that for you, and give you just the starting information that you'll need to get started on this project. We're going to do one of these a day until we get through them all. Okay, so put in your name. You don't need a student ID.
That's my name.
Please do your real name so I can tell if you're understanding things or not.
Okay.
You don't want to log in. You want to join this session. Okay, so we're going to go over this. I've only got 13 people right now. I should have not 43, 20, 18. I got 14 now. So I'm waiting for a couple more people. You guys are all in? You guys are all in? You guys are all taken care of? You guys aren't. Where's yours? You're good? You're good? Good? Good. Okay, let's go ahead and start. Okay, so we're going to talk about the formation of igneous rocks. And as you can see up here and on your screens, igneous rocks form from magma and lava. Okay, can anyone tell me the difference between magma and lava?
Magma is the hot stuff.
Okay, they're both hot stuff.
Lava's the stuff that comes down the mountain.
Okay, good. We're getting close. Lava, what happens, it differentiates where they take place. Go ahead. Either one of you.
Magma is in the bottom of the volcano and lava comes out.
Okay, magma is below ground. Okay, and lava is as soon as it comes above ground, it becomes lava. Okay, magma is anything that's below ground, and lava is above ground. Okay, and magma and lava become different types of igneous rocks. Okay, so again, you got to know that magma is below ground and lava is above ground. Okay, what happens? Which would cool faster, magma or lava?
Lava.
Why lava?
Because it's farther to go.
Okay, it's above the surface, there's not as much insulation, it's going to cool faster. Hello? Hannah, I need you downstairs. Tracy. Okay, so lava, Hannah, Tracy. Lava is going to cool faster than magma. Magma takes a very long time to cool underground, whereas lava, when it comes out on the surface, takes much less time. You know, a couple days, hours, seconds in some cases, whereas magma is going to take years and years and years to cool off. Okay, so when that cooling happens, we're going to grow crystals in rocks. Okay, so you can see this is like granite. Have you ever seen granite countertops? It's got little crystals in it, right? And those crystals are grown as the magma cools. Okay, and so the longer it takes for it to cool, the bigger crystals it will have. Also, the shorter time it takes to cool, the smaller the crystals will be. So which do you think would have bigger crystals? Igneous rocks from magma or igneous rocks from lava? Why do you say lava would have bigger crystals?
Because it cools faster. Less time.
Okay, and what did we say about the size of crystals? What takes longer to grow? Small crystals or big crystals? Okay, so if lava is going to cool faster, would it get bigger crystals? No, it'd have smaller crystals. So magma has big crystals, lava has small crystals. Okay, so these are examples of magma cooling. They have big crystals. And these are examples of lava cooling. They have small crystals. Okay, any clarification questions you have there? Okay, I've got a question for you. Okay, what does crystal size in an igneous rock tell you about how it was formed? Okay, each of you can respond to your answers.
These two.
Okay,
then you can tell each other your answers. So what do you think? You'll still find this.
Okay, so what does crystal size in an igneous rock tell you about how it was formed? Okay, when you've typed your answer, hit the submit button. It's fine to talk with your neighbor, right? If you need to, talk with your neighbor and come up with an answer together.
lava 是在地上，在爆发，可能在下面比较多。两个在中文的话应该是比较可是
Okay, I still got about 30 of you that haven't responded, so talk with your neighbors if you need some ideas, come up with a statement, and go ahead and submit it. Good, everybody's about finished. Highly skilled type. A novel. Got it?
No.
Okay, finish. This is a short answer question. Okay, so what we're going to do next is I'm going to pull up some responses that were given and we're going to talk about them. We're going to see if we agree with them or if we would change anything on them. Okay? So let's take a look.
Will it show up on ours?
Yeah, it shouldn't tell you who it is. It might tell you who it is, but... Okay, so this person said it was formed by either lava or magma and it would have small crystals depending on how long it took to cool down. Okay, I want a thumbs up or a thumbs down if you think that's right or if you think that's wrong. Okay, so 1, 2, 3, thumbs up or thumbs down. Okay, so what are some things that we like about this?
It says how igneous rocks were formed.
Okay, what about it specifically?
Like, it says they were formed by either lava or magma.
Okay. And it would have small crystals depending on how long it took to cool down. Okay, so they could be a little more specific in saying if it's lava, it would cool quickly. If it's magma, it would cool slowly. And if it's lava, it would have small crystals. And if it's magma, it would have big crystals. But they get the gist of it. Okay, so let's look at another one. Okay, it was formed fast and more rapid, so there are more little crystals than having huge crystals in magma. So that one's good. Okay, it tells us that we've got some fast cooling has little crystals, magma has big crystals. They could also tell us to cool slowly, it's magma and has big crystals. Let's look at this one. Okay, it was formed by lava or magma. Good, so if we can tell the crystal size, we can tell how it was formed. And let's look for one more.
Find that novel.
Okay, crystal size in the rocks tells me if the crystals are big, it formed from magma because magma takes longer to cool down. Therefore, it expands. The smaller crystals formed from lava because lava cools down faster, no expanding. Okay, that's very, very good. Let's take a look. Let's take a look at this one. What do we think about this? The crystal size would tell us how old it is. What do you think?
It could because the bigger the crystal, the more longer it took.
Okay, so I like that idea because it might tell us how old it is. The bigger the crystals, the longer it took to cool, right? But it doesn't necessarily tell us how long it has been cooled, right? So if we're just looking at two rocks and we want to say which one took longer to cool, we can tell that. We can't necessarily tell on the crystal size how old it is other than how long it took to cool, right? Once it's cooled, it's not going to change anymore, it's just going to be a rock. Okay, so it doesn't necessarily tell us how old that rock is. But it gets us to a good idea. Okay, so we're going to look at two main types of igneous rocks. We'll come back to how old the rock is in just a minute. Okay, intrusive and extrusive. We have two types of igneous rocks. We're not going to do a lot of differentiation between obsidian and granite and all different types of igneous rocks. We just want these two main types. Okay, intrusive and extrusive. Okay, everybody say those words, this new vocab. Intrusive and extrusive. Okay? Intrusive means it forms below ground. Extrusive means it forms above ground. Okay, what else do we know that's similar to below ground and above ground? Lava and magma, right? So intrusive would be what? Magma. Extrusive would be lava. Okay? Alright, so I have something for you. You've got a picture, and I want you to draw on this and show where the intrusive and extrusive igneous rocks would be formed. Okay? So draw an arrow or something and label where intrusive rocks are forming and label where extrusive rocks are forming.
intrusive 在下面 extrusive 在上面。抛出它们在拉法在哪里？就是抛出 intrusive 的 extrusive。
Okay, we're drawing where intrusive rocks would be forming and where extrusive rocks would be forming. No, because I can't see your graph. I don't know if that means you're supposed to know that. Okay.
I just like the older graphs, the calculations on the PowerPoint.
But they should be maybe finger pointing. Same way
I'll start doing it here.
Drop down arrow. Save.
Everybody
Did it show down here?
I didn't pay attention.
Like that. Okay, I've got most everybody's pictures. I'm missing Maggie's, I'm missing Patrick's,
I texted you just now. Okay.
Dreama, got most everybody else. Okay, so let's take a look at some of these. These look good. Basically, everybody that I've looked at closely got good responses. Okay, so here's somebody's, they've labeled extrusive and intrusive, okay, or lava and magma, or small crystals, large crystals, okay? Got to keep all those relationships together. Good, this one's nice. Okay, so not only they tell us extrusive, they told us it's lava. Not only they tell us intrusive, they also told it was forming from magma. So that's very good. Other information we could provide would be small crystals or large crystals. Okay, so when I look at those, I don't see any real mistakes. So good job. Okay, so let's look at this next thing. We're going to go back to the information that was talked about on the age of the rock. Okay, so age of igneous rocks. We've got to be able to, in this project and for the Dinosaur Center, figure out how old some of these rocks are and some of the fossils. Okay, we use one of the ways. We have two things that we use. We use relative rock dating, which we'll cover at a different time, and this is going to be a little bit of an introduction to absolute or radiometric dating. Okay, absolute means we get a date, right? We can say it's 1,000,000 years old, or it's 10,000 years old, or anything like that. So we get an absolute number. And it's also called radiometric because it uses radiometric dating or radioactive decay. Okay? Radioactive decay, that's where it gets that name of radiometric. Alright, so what happens, and we'll cover this on you have an assignment, a team assignment that's all about how radiometric decay or radioactive decay works and how absolute rock dating works. We're going to go introduce the topic here. Okay, so rocks there are atoms, elements that are radioactive. Okay, we talked a little bit about this in our last unit, but rocks and some elements are radioactive. What that means is, as you can see here, they are a particular type of atom, but over time they change into other types of atoms. Okay, and we can see as we go along, more of these yellows turn into blues. Okay, they're turning into different types of elements. Well, that happens at a very specific time rate, right? So it's predictable. It's a predictable time rate. Okay, so what that means is, if, as an example, if a rock had 100 of one type of element, and we knew how fast those decayed, and if we said they decayed, 10 of them would decay every hour, and we come back to our rock and we see that there's 90 of that first type of element and 10 of the other, how old is that rock? We start with 100, we know that 10 decay every hour. We come back and we find that there's 90 of the original and 10 of the new kind. How old is that rock? How old is that? It'd be an hour old. Okay, if we come back and there's 80 and 20, how old is that rock? It'd be 2 hours old, right? Because we know that 10 of them will turn into the other kind every hour. Okay, if we come back and there's 40 of the original kind and 60 of the secondary kind, how old is that rock? 6 hours old. Okay, so we're starting to get an idea of how this works. Okay, and we'll look in detail at them, at examples of rocks and how long they take to decay and those types of things. Okay, but what's important about igneous rocks is when magma or lava cools, it resets the radiometric clock of the rock. Okay, so it starts at this stage where they're all of one type. Okay, it resets that. And then that decay, or those changing of atoms, starts to happen. And so we can look at and determine how old a rock is, or how long ago it cooled off. Okay? And igneous rocks are the ones that we can do that way. Okay, so let's talk about the other types of rocks. Sedimentary rocks are made up of other pieces of rocks. Okay? So we might have chunks of igneous rocks inside of sedimentary rocks. Okay? And so they don't work very well for this type of dating, because we don't know when that sedimentary rock formed, because we're using pieces of other rocks that came from somewhere else. Does that make sense? You know, it's like taking, so the example that you use on your thing is, well, I'm not going to use that one, because it confuses those things. But if you take something that's old and put it into something new, but you figure out how old the pieces of that new thing are, you're not figuring out how old that new thing is, you're figuring out how old the pieces are. Does that make sense? We'll cover that when we talk about our law of inclusions and we talk about radiometric dating. So the gist of it is that igneous rocks are the ones that we can date using radiometric dating. Okay? Metamorphic rocks, are also helpful in that. Sedimentary, not very good. Okay? We can't really use radiometric dating very well with sedimentary rocks. Okay? So let's take a look at some examples Okay, we're just going to look at some examples of igneous rocks so we can start to get an idea of what they look like. Okay, so what in this picture helps me to know that this is a igneous rock?
Crystals.
Right, we can see crystals in it. Okay, we can see crystals in this one, and you should be able to see them on your iPad or your computer a little better, but they're little black and gray differences. Can you see those? Okay, it's hard to see it up here, but on your picture it's best. Okay, so that's an example of some larger crystals and some smaller crystals. Okay, these are both probably what type of igneous rock, and we want extrusive or intrusive. Okay, why do you say extrusive?
Because they are smaller crystals.
Okay, so we have to compare them. Let's go back one. Are their crystals bigger or smaller than the crystals in this one?
Bigger.
They're bigger, okay? So the question is when does it become extrusive or intrusive? If you can easily see crystals with your naked eye, that means that it's an intrusive rock. Okay, that means it cooled from magma or instead of lava. Okay, if they're really, really, really small and you kind of have the strain to see them, or you can't see them, that means they're extrusive. Okay, so these are both intrusive rocks. They have large crystals and they came from magma. Okay, these ones are two types of igneous rocks. They're called pumice and scoria, and then we don't see any crystals, right? You might see these in like gardens and stuff. They're really rough. They have lots of air pockets. They have those air pockets because they are extrusive and they're mixed with air. Okay, pumice sometimes will often float. Okay, it's got so many air particles in it, and it will float. Okay, when rocks, igneous rocks, cool fast, the crystals don't have time to form, and so they're very, very small. Okay, here's an example of obsidian. You've probably all seen obsidian. It has no crystals in it. It cools so fast that no crystals can form. Okay, so if you see obsidian, you can know it's an igneous rock, and you can know that it cools so fast that no crystals can form. Okay. Okay, you have one question. Which rocks cannot be used for absolute or radiometric dating? Which rocks cannot be used for absolute or radiometric dating? And this is our last question, and then it'll be your time. 20 minutes. Ken, I think I still need you to respond. Okay, I think that's everybody. Okay, one of these no answers is me because I got this computer running on it. But based on this, we can see 47% of you said sedimentary, and that's the correct answer. Okay, sedimentary is the rock type that we cannot use radiometric dating on. Okay, or absolute rock dating. Okay, so you'll need to remember that, and that'll be helpful in this project. Okay, any questions? Okay, let's all get to work. Remember, I do have some team assignments up here. Your assignment choice grid is up to date, and it should be, I have one that's under construction, but you'll know that it's under construction. Okay? But there's plenty to get working on. Stop it.
Let's go.